Okay, so how about number 34, wherein we have here the two cases. Calculate the current in and the potential difference across each resistor in the circuit, wherein in this case, the battery's resistance is 0, and on this case, the battery's resistance is 2 ohms. Now, let's try first to solve letter A. Now, so from here, if you follow the circuit, so this battery is in parallel with this 10 ohms, and so this battery, so this resistor, we're gonna have it in series, and then after that it is parallel on 10 ohms and 20 ohms. And so first we can solve for the resistance of this, and the total resistance for that is 1 over 10 plus 1 over 20. And so the total resistance for that is, solving for that would be 6.67 ohms. Now, how about the total resistance for everything? That is simply 6.67 ohms, which is a total of this, plus another 2 ohms, and the total resistance of the circuit, that would be 8.67 ohms. Now, after that, we need to solve for the current equals to IR, and therefore the current now is the voltage divided by the total resistance. And so that would be current, that is 12 volts, divided by the resistance, which is 8.67 ohms, and therefore the value of the total current, that would be 1.38 amperes. And so let's try now to calculate the resistance here. Let's try now to calculate the voltage on this part. And so the current that keeps on flowing here, that is 1.38 amperes. And so this one will gonna be 1.38 amperes. And so the value of voltage, that is 2 ohms, multiplied to 1.38 amperes. So 2 times 1.38, that would be 2.76 or 2.77. And so this one will gonna be like 2.8 volts. Next, so there is a voltage drop, so we're gonna have a voltage drop, and that is 12 volts minus 2.8 volts. So 12 minus 2.8, so 12 minus 2.8, that would be 9.2. So here we're gonna have 9.2. And remember, since this is parallel, we divide the current, but we're gonna have the same voltage, and so the voltage here is 9.2 volts, and then here also the voltage here we're gonna have 9.2 volts. And so what is now the current here? So the current at 10 ohms, that would be voltage over the R, and that would be 9.2 divided by 10, and so we're gonna have 0.92 amperes. And then the current, 20 ohms, again that is still V over R, and that is 9.2 divided by 20 ohms, and that would be 0.46 amperes. And so again, if you try to answer the question, 0.92, that would be the current for this, 0.46, that would be the current for this, and the voltage for 2 ohm resistor, that would be the 2.8 volts. Now next, let's try to consider this one wherein the battery has an internal resistance. Now you might want to think this as a resistor. Okay, so here we're gonna have 2 ohms. And so computing now for the total resistance, well, this one is in parallel with each other. So this would be like 4 over 2 resistors. So 4 ohms over 2. And so the total of this resistance is 2 ohms. And if we try to look at the circuit, so the total resistance now, that would be 2 ohms for this part, plus 2 ohms on this part, plus another 2 ohms for the resistance of a battery. And so the total resistance will now become 6 ohms. And we'll try to get the current now. That is the total voltage over the total resistance. That would be the current. And so we're gonna have now 6 volts over 6 ohms, and the current now would be 1 ampere. And so from here we can take note now that the current coming from the battery, from the resistance of a battery, so the EMF is 6 volts, and then we're gonna have 2 ohms, and so that is current multiplied to the resistance, and that will gonna give us the voltage, and that is 1 ampere times 2 ohms, so the potential difference now, that would be 2 volts. The potential difference now, that would be 2 volts. And so here the voltage drop is simply 6 volts. So 6 volts minus 2 volts, we're gonna have 4 volts. So from here we're having 4 volts. Okay, so the potential difference across this wire is 4 volts. And then how about the current that's gonna flow here? That was still gonna be 1 ampere. And so the voltage now, that would be 2 ohms times 1 ampere, and then this one we're gonna have 2 volts. And so from this portion, we're gonna have a voltage drop of 4 volts, minus the 2 volts, and that would be 2 volts. So what we're gonna enter here is another 2 volts. So again, let's try to recap. We have here the potential difference, that is the resistance times the current. So that would be the working voltage that will gonna come out from this battery. 6 volts minus 2 volts, that is 4 volts. And then once again, there's like a potential there's like a voltage drop, that is 4 volts minus the voltage of this, that is 2 volts. And then here we're gonna have the same voltage since they are parallel. And so what's now the current here? The current here, that is simply V over R, and that is simply 2 volts over 4 ohms. And same with this concept. And so the current now is 0.5 amperes. So let me just show now the final answer. So at 2 ohm battery, okay, the current is equal to 1 ampere, and the voltage is equals to 2 volts. At 4 ohm battery, so we have 4 ohm resistors, the current is equivalent to 0.5 amperes. Same with this. And then the voltage at the 4 ohms, that would be 2 volts. Okay, so again, was a summary for this. So it's like from this part, it's like we are computing the total resistance together with the resistance of the battery, and then we get the current. After getting the current, we simply multiply it with the resistance of the battery, and that would be the potential difference across this wire, and there will be a drop on the voltage. So 4 volts, so 6 volts minus 2 volts here, then there's a drop of 4 volts minus 2 volts, and then another one. So, and therefore we're gonna have here the same voltage since they are parallel. So 2 volts here, 2 volts here, and then we can get the current. And that is for number 34.